Welcome everyone, and I hope that everything is going great. I'm really sorry for being late. Shit happens with the connection sometimes, but for sure that it will be okay till the end of the session. So, hello everyone again, and welcome, dear authors and invited guests. Welcome to our technical session, first technical session for today. Good morning, good evening, good afternoon, depends on the time that your time zone is. And it's my great pleasure to welcome you to the fifth World Conference on Smart 2021 and Global Knowledge Research Foundation. We are thankful to everyone to present on this platform their great papers to go along with the digitally for the conference, and these under these unpredictable circumstances of COVID-19. We know that we are all suffered from the distance, the pressure, and the change in regulations. And thanks for making this conference more productive. Also, we wish everyone and their families to protect it for protected time, and for sure we will all together pass through this very soon. We will enjoy the 2 days conference, and it will be knowledgeable and interactive sessions based on your contribution for sure. So we want to first to introduce our chair for today. Let me just share my presentation, and based on that we will start with the sessions. I'm really sorry, it's a little bit messy at the beginning. So our first technical session will be with Dr. Tuba from Serbia. Most welcome, doctor, and thanks for your time. In brief, if I wanted to introduce your profile, uh, which is really rich, and again, sorry, and again, sentences and words would not be enough to explain your contribution to the knowledge and academia. I'm really sorry because I've really messed with the files. I'm really sorry for that. Okay, so in brief, Dr. Tubal, the vice reactor in international reaction in Sangadium University. I'm sorry if I'm spelling it incorrectly, in Bulgaria, Serbia, and he was the head department of mathematical scientist at State University of Novi Pazar, and the dean of graduate school of computer science at John Nesbitt University. He ranked in the 2020 the world's top 21 scientists list by Stanford University for 1984. He was assistant professor at computer science and director of computer science at the University of Belgrade. From 2001, associate professor at faculty of mathematics at the University of Belgrade as well. And from 24, he was also a professor at computer science and dean of the College of Computer Science. He was teaching more than 20 graduate and undergraduate courses, from SI design and computer architect to computer networks, operating system, artificial intelligence, image processing, calculus, and queuing theory. His research interests include natural inspired optimization applied to image processing, computer networks, and neural networks. So as we can see, it's the trends of this age, and unfortunately for some candidates it would be hard, but we are pretty sure that it would be great for the presenters to gain the experience and the feedback from an expert such you, Dr. Tuba. So first we wanted to start with our first presenter, Mr. Sood Saderman from the United Kingdom, and his paper is presented as classification of segregate lumbar spine from lumbar spine spontaneous deduction, transfer learning of deep convolutional neural networks. And on behalf of your co-author, could you please just share your screen and start the presentation? I will stop sharing from my side and make it possible. Yeah, we can hear you. Could you please just share your screen?
Let me share my screen. Is it okay?
Yeah, it's clear.
All right. Okay. Thank you.
Thank you.
Okay. Thank you for that. Hello, everyone. Good morning, good afternoon, and good evening to you, wherever you are. My name is Sudirman. I'm here to present the result of the research work that my colleague and I have done, entitled Classification of Sagittal Lumbar Spine MRI for lumbar spinal stenosis detection using transfer learning of a deep convolutional neural network. So I'll just go deep into this. So let me start by describing what lumbar spinal stenosis is. It is a narrowing of spinal canal in the lower part of our back. Um, when this, as you know, our nervous system starts from our brain, and then it's transferred to the rest of our body through nerve bundles and inside the spinal canal at our uh, spines. And when the spinal canal narrows for any reasons, the nerve bundles inside it can be pinched and squeezed and creating pain sensation. Um, LSS sufferers may experience pain or numbness in their legs, and they may also have troubles or problems walking distances. And in some more severe cases, they may have difficulties controlling their bowels and bladders, and they can even basically incapacitated. The most common cause of spinal stenosis is osteoarthritis, uh, but could also be due to accidents or excessive heavy weightlifting. LSS is diagnosed usually by inspections of the patient's lumbar spine MRI by a physician, who usually starts by looking from the sagittal view or the side view um, of MRI and find the mid-sagittal plane or the middle plane of the sagittal view. This is basically the best view to get to view the lumbar, the intervertebral disc. Basically, the usual suspect in the cause of uh, LSS. Um, Often, the physician then proceeds by inspecting each IVD through the axial view, which is the ones on the right here. Um, Recent advances in medical image processing allow the applications of computer algorithms to help physicians carry out these procedures. Some of these algorithms work on mid-sagittal view, and while some works on the axial images. For example, I give two examples here. The image on the left here is from a paper that describes an algorithm that works on sagittal images. And the one on the right here is from our previous paper published on PLOS ONE journal last year that describes an algorithm that works on axial images. These algorithms require suitable images and input as inputs, and they cannot just take any images. For example, if the algorithm requires mid-sagittal images, if you give lateral or sagittal images from the sides, for example here, this one, it might not work. Also, since the patient data repositories contain more than just the required images, uh, then there needs to be a process that selects the suitable images. And this process is often done manually. So that is pretty much the rationale of our research, and bring us to our research objectives, which are three. So first one is to develop an image classification algorithm that can select all the sagittal images that are in the vicinity of the mid-sagittal plane from a database of sagittal MRI images. The second objective is to develop the ground truth dataset, which is a database of sagittal MRI images, which has verifiably accurate classifications. And lastly, to investigate whether there is any performance differences when using either modality, either T1 or T2. And if there is, then whether the difference is statistically significant. The material used in our research is taken from our lumbar spine MRI dataset, which is available publicly on Mendeley data. This dataset contains anonymized clinical MRI studies of 515 patients with symptomatic back pains. The dataset contains 48,345 T1 weighted and T2 weighted transverse, axial, and sagittal images. So basically a mix of images. And from this data set, we took 19,176 sagittal images, which consists of but over or just below 10,000 T1 weighted and just over 9,000 T2 weighted images. And we also get the help from radiologists, and based on the advice from these expert radiologists, we categorize the sagittal images into two groups, namely mid and lateral groups. Now, the figure here that I show an axial view of one IVD in patient's lumbar spine. The lines are the intersections with a sagittal plane. The yellow lines mark sagittal planes in the mid group, it's basically in the middle, which can be used for further analysis, and the red ones, which is need to filter out. And we also have developed a methodology to verify the accuracy of these. So, which I'm not going to go into the detail, and you will be able to look at that in our paper. So here we saw the population size of the data set, which is about 9,903 for T1 weighted, 9,273 for T2 weighted, and then the distributions for the mid and lateral for each. And here we saw that the population size for both groups are roughly equal. So that's the materials, the method. So as for the method, the dataset is used to train an inception ResNet P2 model. The reasons why we chose this model is because it is one of the newer generations of DCNN that has gained popularity in the classification and annotations of medical images. We adopted a methodology called transfer learning that transfer the learned network parameters of the model that was pre-trained using ImageNet database, and then retrain it using our dataset. So briefly, I'm just going to show the transfer learning method. So by this diagram, so it starts by loading the pre-trained model and then replacing the classification layer, and then set the training options and parameters, and then use the training, the images from the training datasets to retrain the model. Once it is retrained, and then we assess the performance of the model using the images from the test dataset. As for the performance evaluation metrics, we use 4 metrics, which are overall accuracy, which measures the percentage of correctly classified data in the whole dataset. Precision metrics, which basically gives the percentage of the data correctly predicted as belonging to a certain class from all the data predicted as belonging to that class. Recall, on the other hand, is basically a different metrics, which is a percentage of the data correctly predicted to belonging to a certain class from all the data that actually belongs to that class. And the last one, which is F1 score, which is the harmonic mean of the last 2 metrics. So the data set
sorry for interruption, but we have 4 minutes more.
Yeah. So the data set is split into 80-20 ratio for training testing purpose. The training is further split into smaller training and set and validation set. And the model is trained using small training set, and the validation set is used to provide an unbiased estimate of the trained model accuracy during training. And the model training is optimized using stochastic gradient descent with momentum technique. And then the training is done in small batches of 10 samples for 4 epochs. This is to ensure that it's basically stable. And the order of sample is basically randomized or shuffled. The initial learning rate of the fixed layer is set to 10 to the power of -4, which is very small. And then the classification layer is set to be higher because we want that to train to the new data sets. Since we need to assess the suitability of each modality, the T1 and T2 dataset are used separately. The experiment is repeated 20 times so that we can perform a meaningful statistical analysis. And when we train it, the training time ranges between 750 to 765 minutes. And we make sure that each training session, the validation accuracy reach a plateau or stable state, which I can confirm from this graph over here. So this is the validation accuracy during training, which is pretty much like it's plateauing at epoch 4.
Yeah, could you please just conclude? We have 1 minute more.
Okay, as far as the classification results, so we have the train model is used to predict these results, and the finding that we have is that the T2 result is better than the T1 results. And we also perform statistical analysis to this using cosmographic Barter test and the t-test hypothesis testing, which we show that by using this, by observing the p-value of the t-test, is that can confirm that the T1 and T2 data sets is statistically significant in terms of performance. Okay, I'm not going to read the conclusions. So if you have any questions, then you can ask me in that. Thank you very much.
Okay, thank you for the presentation, and it's your turn, Dr. Tuba, if you have any questions, since we have nothing on the chat, and we will get back to the audience after that if there's any further question based on that discussion.
Okay.
Yes, maybe just a short explanation. How did you initially select 20,000 out of 50,000 images?
All right, the 50,000 consists of axial and sagittal images. So we only select the sagittal images. And some of the sagittal images are kind of like repeated. For example, like for the same patients, and it's taken for many times. So we kind of like.
So you have to do it manually first.
Yes, yes. So in our research, we only select mid-sagittal images from a collection of sagittal images, not from axial. So we kind of like do that pre-filtering at the start.
Okay, thank you.
All right, welcome.
Okay, any other question, please, from the audience? Okay, since we don't have more questions, let's move to the next presentation, please. By the way, I'm pushing a message to the presenters to make sure that they will be ready on the next turn. And I will use this one, just I will raise it when we have time limitation. So just when I raise it, please try to to conclude, because you'll have, let's say, approximately 3 times before raising it. And now we wanted to welcome Mr. Abdul Hadi Hamil from Bangladesh. He want to contribute in behalf of the co-authors the paper titled as Contribution of Robotics in Medical Application, a Literacy Survey. So the floor is yours. Good luck, and we will enjoy the presentation for this interesting topic. Could you please just share your screen and go ahead?
Okay, thank you so much.
Thank you. Yeah, share it from your side. Yeah.
So I will present my screen to you and
Yeah.
describe my presentations.
Yeah. And in advance, if any of the presenter has a technical issue, you can drop the presentation and we can share it from our side in case of any technical difficulties.
Okay, there is a problem with my
no, I can see it clearly. Please start. Please remember the time limitation. And again, when I raise our friend, you have to jump to conclusion. Okay, go ahead. We are all listening. Thank you.
Okay, can I start?
Yes, sure, go ahead.
Okay. Okay, so good day, everyone. My name is Abdul Hadi Hamil, and my university name is Daffodil International University. I am from Bangladesh. So thank you so much to providing this opportunity to present my work to all of you. So I am here for present our research work, and that is contribution of robotics in medical applications, a literary survey. So here is our outline, and firstly, I would want to talk about the summary of our research paper so that everyone gets a very good and clear idea about our work. So this paper gives a general summary of robots medical science, following a discussion of the basic idea of a medical robots, the future of medical robots, and several sort of medical applications are also examined. So one of the goals of this project is to look into the issues and limitations that medical robots face. This paper gives several graphs and charts for a year-by-year discussion of medical robots, giving a comprehensive pictures of what has happened in medical robots during the last 30 years and what will happen in the future 30 years. So then, background study. A variety of characterizations for distinct types of robots aid in the descriptions of these disparate devices. Mechanical innovation is making its way into a variety of operations. Rethinking how present technologies are implemented and empowering new methodologies, computerized arms, mobile phones, plants, and telemechanical devices are all examples of robots. They can also be animated, semi-animated, and alive. Dynamic devices are completely programmable and can run errands on their own. One may imagine a doctor entering three-dimensional registered terminology data into a computer, then programming the computer to direct a plant to remove certain bone sections. The majority of a microsurgical assignment and chest wall medical procedure have comparable fundamental properties, such as limited access to the working volume inside the body, which is typically achieved by using small entry sites through the stomach or dividers. These carts serve as rotation point for monitoring devices while also limiting the growth of devices within the body. Robots may be found everywhere, from science fiction to your local emergency room when they are transferring medical care. These robots like R2-D2 from Star Wars from then a humanoid, but they are having a significant impact on the field of medicine. The technique known as container endoscopy received FDA approval a year ago, but current innovation may finally deliver on all of its promises. Okay, so then the evolution of 5th-generation surgical robots. So here I want to discuss about the generations of surgical robots. Firstly, the first generation is stereotaxic robots. Second generation is endoscopic robots. Third generation is bino-inspired robots. Fourth generation is microdots, and the last generation's robot is autonomous systems robots. So here, these factors all require underpinning with the highest level of evidence to develop the optimal multidisciplinary approaches to integrate surgical and aesthetic and allied specialists to deliver robotic surgery into its next stage of innovative evolution. Then, robotics in medical science, past, present, futures. So originally, clinical software robots were delivered from current robot because they are broad and address innovation engineers as well as end clients. Job-based classification can be more useful. So there are some roles like passive role. The job of the robot is restricted in extension or its contribution is generally okay. Restricted roles. The robot is answerable for more obstructive assignment with the higher danger. However, is that yet confirmed from fundamental bits of the technique. Then active roles. The robot is personally engaged with the technique and should I stop?
No, but you have 3 minutes. Sorry.
Oh, I have 3 minutes. Okay.
Yeah, just a reminder.
Okay. So then I want to tell about the table of past, present, future robotics in medical science. So here we can see the year of 1985 to 2019, the progress of medical science. So first of all, in 1985, first robotic surgery performed. Then this surgery procedure continuous upgraded, like we can see in 2013, it's over 5 lakh surgical procedure performed worldwide with the Vinci. And in 2099, over 5,000 Da Vinci surgical system installed worldwide, 6 million surgeries globally. So then, if we can see the surgical and oncology overview from the year 1997 to 2017, we can see that there have been a significant advancement in the surgical and oncology field from these years, and that will continue for the next generations. Okay, then robotic applications. The applications territory, control methods, actuator, mathematical setup, and other factors can all be used to organize robots. So some of robotics applications are given here for medical transportation robots. Okay, so first one is disease patent robots, then robotics prescription systems, then cardiac device, soft rivers, and many more. So the future of robotics in medical science. Early applications of medical and mechanical technology were difficult because specialists needed a complete view of the task. Engineers required to visit the working room and construct the genuine boundaries that they considered were proper for a strategy in the manner. Slices were compiled to the perfect district by the robot's unique region structure. So then medical robots market share. In various region, robotics market shares are different. Like America, the share is 39%. In Europe, the share is 35%. East and Africa, Middle East and Africa share is 7%, and the Asia Pacific, the share is 19%. So here I am for the conclusions. This research showed the evolution of robotics in medical field. Robotics application in medical areas, IoT-based robotic system in medical system. So this work present an organization literally assessment of robotics applications related to medical science from the past to the future. However, in the future, the work will lead to new invention in IoT-based medical robots. So thank you so much. That's all from me. Any questions?
Okay, thank you. Thank you for the great presentation and great contribution. So since we don't have questions on the chat, we will get back to Dr. Tuba for his input and valuable feedback besides the question for sure. So could you please just let us know your feedback and idea and any idea, Dr. Tuba?
Yes. Just the last slide about the percentages. Is it the percentages of how many robots are produced or bought in these regions, America, Europe, and so on?
Okay, so I work in market shares, but I don't add in our paper how many production in America robots happened. So I work only market share in medical robotics.
So market share is what percentage was bought in that region?
Yes.
Okay, okay. Thank you.
Welcome.
Okay, thank you. So again, any question from the audience, from the participants? Okay, you're lucky. You did not get very hard questions. Let's continue with the next presenter. I want to stop your screen sharing. Let's continue with our next presenter from Kuwait with Ms. Hawra Ms. Hawra Al-Mutawa on behalf of her co-authors, and today she will present the paper titled as Human Resource Information Systems in Healthcare Organizations. So, Ms. Hawra, could you please just share your screen and go ahead with your presentation? Again, I will raise our friend when you have 3 minutes, sorry. And for sure, any question could be shared on the chat box by the audience, and I will moderate them to the presenter. Okay,
Are you
so
seeing my screen now?
yeah, we can see it clearly. Go ahead,
Okay.
please. Thank you.
Hello everyone, my name is Hawan Mutawa and today I'm going to talk about my research topic, which about human resource information system in healthcare organization. A human resources information system is a system who in charge to manage of an organization employee resources, allow for human resources professional to be an important player in any organization. Also, this system gives the abilities for this professional to be more effective, efficient, and have high ability to support the strategic decision-making process in any healthcare institution. Nowadays, existing for a such system in healthcare institution is essential for providing efficient, effective service to achieve high-quality patient care and satisfaction. And there are many definitions for the human resource information system. And one of the interesting definition is by Sislu Hero, and he defined it as a systematic procedures for collecting, storing, maintaining and displaying and validating data required by organization on human resources, their activities, and organization unit characteristics. Also, people have to have a clear understanding about the difference between the definition of healthcare information system and human resources information system, where the human resources information system is a component or a part of human resources of healthcare information system, and also the human resources information system focus on the workers themselves, while the healthcare information system focus on the patient. The healthcare information system also have two attributes, the functional attribute and the non-functional attribute. And both of them has a huge impact to improve the performance of working staff in hospital. But most of the healthcare institutions do not concentrate on the non-functional attribute, which will affect the healthcare institution negatively. The functional attribute include the employee database, and which is a centralized database that organizes and manage all the employee data and information. The employee life cycle, and it includes 5 stages, including the recruit, onboard, develop, retain, and offboard. The hiring process, which is a little bit long process, include for more than 8 stages, including the identifying the hiring need, planning, screening, posting the promotion, interview, background check, and the last stage, onboarding. The payroll system, it's a system that involves everything that has to do with the payment of employee and filling the employee of employee taxes. The non-functional attribute of healthcare human resources information system include the ethical issue, legal, safety, quality, privacy, social, professional, and standards such as the policy, rule, and regulation. The European Union Healthcare Commission released a report in 2016 where it states that the healthcare information system was lacking of non-functional attributes. And that's why in this research we focus on the implementation of the non-functional attribute in healthcare information system. The methodology, the study is based on conceptual approach, and an approximate and exploratory qualitative method is used to ensure the reliability and the validity of the questionnaire and to better fit to Kuwait in terms of culture and terms of culture similarities. And due to the time and cost concentrate, the questionnaire was designed online using the Microsoft Forms application and distributed using WhatsApp and email among people living in Kuwait. The survey designed for a particular group of people, as you can see here, the cross-section of Kuwait population and hospital staff, doctors, patients from both gender with different education group and with from different ages. Also, the sample consists of 128 participants. The survey is divided in two parts, completed by all the respondents. The first part is the demographic questions that consist of four questions related to the personal information about the company and the person who want to fill the survey. The second part is the main part, which consists of five sections, which is, as you can see here, the usage, the safety, the privacy, legal, quality, and ethical. Each section refers to several observations about human resources information system, and most of the questions are statements with a Likert scale 5-point system. The form is in both English and Arabic language to be more convenient for participants living in Kuwait. The demographic summary, as you can see from the table, are from both gender. Most of them are women, and from age between 18 to above 44, and most of the participants, about half of them, were between 24 to 34 years old, with different education levels, starting with less than high school to higher education, and most of the participants having bachelor degree. Also they are from diverse group, and most of them patients. When we ask the participants about the usage of healthcare information system, human resources information system in their organization, 83% of them answering that they are using it, while only 17% have never used it in their organization here in Kuwait. Also, about the duration of the use, as you can see here from the pie, about 43% of them are using it for more than 5 years, while 34% of them are using it for less than 3 years, and 24% using this system from 3 to 5 years. The Bayesian correlation coefficient is used to statistically measure the relationship between the independent variable in this research. The value of correlation, as you can see in the table, between the ethical and the quality indicate the strong positive relation. Also mean both the relation are strongly correlated with each other. Also, the value of correlation show a weak correlation between the safety and the privacy, and between the safety and the ethical. The result of the questionnaire indicate that most of the participants have used such a system in their work for more than 5 years, and there is a strong need here in Kuwait to such a system. Also, the participants have some concern about the system will ensure their safety and privacy. The survey further assists in generating the functional and non-functional requirement for the report application. The limitation of the study, the sample selection process for the study include only few group of the system user, such as the patient, doctor, hospital staff, and the manager. The selection process was random, and it is only a subset of the entire population of Kuwait. As a result, this limitation would influence the generalizability for the study, since the random sample only include a subset of Kuwait population. Additionally, the sample size was small and include numerous independent variables which require to be controlled. Such small sample size introduce limitation for a lack of estimating parameter available for large sample to include consistency and efficiency. The recommendation is to build a new model for human resources information system, such that Kuwait legal issues are properly addressed in the system. Also to build a new model for human resources information system, such that the local privacy issue is properly incorporated in the system. Also improve the model of human resources information system, such that the safety and the security assurance meet the international standards. Modify a flexible human resources information system to support the continuous improvement. In conclusion, Kuwait needs to invest more on the software and hardware in order to implement human resources information system. Also, it needs that such a system has a significant role to support the human resources function The human resource information system also have an important role to qualify the delivery of effective and efficient service in the medical care institution. The healthcare, and also in the healthcare institution, the system should have a clear strategy to overcome any issues. And most of the important three issues that recently have a biggest impact on the system are the safety, digitalization, and the privacy. Thank you. And you have any question?
Okay, thank you. Thank you for the presentation and for the contribution. So now we want to get back to our host for the feedback questions and for sure constructive input in this interesting research. So could you please just share with us what do you think, Dr. Tuba?
Yes. Well, you mentioned that the sample was small, but actually maybe we need some clarification. Why was it so small? And what kind of conclusions can you make? And what is random? Is it random from the whole population or from the people that had experience with the system, or what random really means?
It's random from the people who have experience with the system, and it's only a 128 participant who is do the survey. That's why it's a small sample and it's random.
Was it very difficult to get maybe 1,000?
Yes, a little bit here in Kuwait. It was difficult also because of the time was only for 4 days that I have.
Yeah, okay, thank you.
Okay, so thank you for the question, Dr. Professor Tuba, and thank you for the contribution, our valuable researcher. And now, since there is no questions, let's move to the next presenter. Now we will talk about another interesting topic with a researcher from Poland. We have Mr. Tukraz, and on behalf of the co-authors, he will present the paper titled as Simultaneous Measurement Reading from More Than One I band 3 wideband. So we are all listening to you. Could you please just share your screen and go ahead with the presentation? Remember, we have 15 minutes, and I will raise a flag when we have the countdown of three minutes. Thank you. And everyone for sure can push the questions during the presentation to the chat box. Thank you. Go ahead, please.
Yes, of course. So I'm sharing the screen.
Yeah, let's take it. I will stop from my side. You can take it easier. Yeah.
Okay. So let's try again. Share. Yeah, the screen. Okay. Now.
Okay, counting down. We can see it. Yeah, we can see it now. Okay.
Okay, thank you.
Thank you. Thank you.
I hope you can see, you can hear. Mr. Chairman, ladies and gentlemen, my name is Krzysztof Tokarz, and I'm from Silesian University of Technology. And today I'd like to present you the results of our research on simultaneous measurements reading from more than one MyBand 3 wristbands. First, of course, short introduction. I'll tell a few words about the literature topics, next research with the results and discussion of the results of the research, and at the end conclusions and future work. All the research was done in cooperation with Norwegian institutions. We have two colleagues there, and we work with the similar topics for a few years with Paweł Mielnik, who is a medical doctor, and Marcin Wojcik, who is a computer scientist. We can observe the growing popularity of using wearable devices like, for example, smartwatches and wristbands. But typical applications of these devices are rather fitness. So measuring the heart rate, counting the number of steps while walking or running, tracking the path, measuring the distance, or calculating the whole energy spent, so calories, of course. But such devices can be used also for health monitoring, and this is the topic that we are working on. We have found we have found such topics like heart attack detection, fall detection, especially for elderly people, monitoring the process of rehabilitation, and also monitoring the behavioral health, like, for example, depression and stress. And so we formulate the problem of our research that we want to measure the raw accelerometer data that we can get from our MyBand3 devices, but simultaneously from more than one device. Yes, so we can imagine that we can put such devices on 2 arms and 2 legs and monitor the, for example, rehabilitation process. In the literature, we have found examples of using such wearable devices in monitoring the health, for example, for fall detection and prediction also. Monitoring of chronic arthritis patients, this is the topic that we are interested mostly. Monitoring of pregnancy, sleep analysis, detecting emotional states for the elderly, real-time monitoring of alcohol craving, monitoring effectiveness of rehabilitation exercises and also sport exercises, and mentioning the reading the data simultaneously from more than one device. We have found in the literature computer-assisted systems for group classes of exercise-based rehabilitation. And here the wristbands are supported with Kinect sensor. So this is interesting. Another topic was creating the computer network, personal area network, so small network with several smart devices collecting data during physical exercises. And also system of several wearable sensors connected together to monitor sports rehabilitation. And basing on this, we have thought that it will be interesting because we haven't found the research on simultaneously collecting data from more than one MyBand device. We will use up to 5 such devices to inquire the parameters of data transmission from several bands at the same time. And also the difference of reading times, because you know the readings can suffer delays. So we wanted to check if these delays are long or not. And also differences in the data sent by devices, so we can talk about the accuracy if the measurements are similar. The whole research process looked like this. We had such MyBand3 wristbands. They send raw data from accelerometers. It is possible using these devices to read the accelerometer data directly using Bluetooth Low Energy link to the central computer. Central computer collects data from all these devices together, gives the timestamp to the data, and stores it in text file for future processing. And files are analyzed in MATLAB environment, and I'll show you few plots how all this data behaves. This is how does Mi bands look like. They were all connected on the same rod to make the movement stable and the same for every device. And 3 research scenarios we have used: laying still, moving up, down, slow and fast, and also rotating this rod to observe the measurements. And let us start the discussion of the results with time analysis. It was a situation while devices were standing still, and we were observing the differences between timestamps, what was the minimum, maximum, and mean, and occurred that if we have up to 4 Mi bands connected together, the mean time, the mean difference in time is, we can say the same, so something about 45 milliseconds. But while we connected the 5th wristband, the growth of mean time was significant. Yes, something about 20%. Accuracy analysis, we have detected the peaks while moving, and the mean was calculated and compared to the highest reading, and the results are like this, that the mean error is quite small, is something about 3.3%, in a y-axis and 2.3% in z-axis. The x-axis wasn't moving, so that's why only these two axes. So as you can see, the accuracy is quite good. And this is the most interesting, I think, result, that this is the plot of rotating all 5 Mi bands together. And as you can see here, we can observe the lag. This is 4 results from 4 Mi bands, and here is the 5th one. And as you can see here, we can observe the lag that is different for different rotations. So this lag is very uncommon for us, and we don't want it, but you know, it happens. And these are plots for slow and fast movements, and we can observe this lag here again. Here we have the peak from 3 Mi bands, and here we have the same peak from 4th, and here from 5th Mi band. So while we move this Mi band slow, this is movement up and down. We can detect which peaks correspond each to other, but if we have fast movement, it is impossible to detect which peak corresponds to which in another Mi band. That's why from our observation, the conclusion is that the frequency of movement cannot be very high. So just the slow movement we can detect, and we can compare, and we can analyze. And additional phenomena we have observed that after such lag, we have such accumulated readings, we can say. So every lag is followed by such accumulated readings. So for example, here more than 10 readings almost at the same time. This phenomena can be used for improving the accuracy for calculating the average value, but if we want to, for example, analyze the movement, simultaneous movement of 2 legs and two arms, it will not help us. So we will still suffer from these lags. So going into conclusions, it is possible to read the data from more than 1 Mi band. We have measured up to 5 simultaneously, but more than 4 suffers the errors in time readings. The accuracy is quite good, but appearance of the lags reduces the maximum frequency of the movement that we can analyze. But we plan the further research to find what is the reason of these lags. Yes, because maybe the lags occurs not because of the construction of Mi bands. So maybe they are generated by Bluetooth Low Energy Protocol. Maybe they are generated by the computer, by the central computer that we used. So we plan to make further research to find what is the reason for appearance of these lags. Okay, so thank you very much. This is everything I wanted to share with you.
Okay, thank you. Life is easy with your research results, and I hope that the questions of Professor Tuba would be easy as well for you. So, Professor Tuba, could you please just let us know what do you think, your input and your questions, please?
Yes. Well, I think the luck mainly depends on the hardware devices that you use. So what was your main device? Was it mobile phone or some desktop computer with Bluetooth module? Or
yes, it was laptop with Bluetooth module and with Linux operating system, because the software that can gather data from Mi band devices is written in Linux, in Python. So we think that it's possible that the reason of this lag is the computer, because it was not very fast computer. So we have to make further research to check it.
no, actually, you don't have any control if you use the standard computer and standard software, because it's doing what it wants to do. If you want to have control, you have to write your own software, and then you know what are you reading and at what time.
Exactly, and Yes, you are right. And the software that we used, this is not this original. This is not the proprietary software from Xiaomi. This is the software that was partially written by our Norwegian colleagues. So this is software that we know, we almost know what's happening,
Oh,
but
yeah,
we have to make the further research.
yeah. Okay, okay. Thank you.
Thank you very much.
Okay, thank you for the presentation and the questions. Since we don't have more questions, we will move forward to the next presentation. As we have diversity with the authors, the presentations, also we have another diversity with the way that we are presenting the ideas of the research. And now the next presenter preferred to make it using a video, and I will share it from my side. So let's see what the presentation include. It's titled as a new academic field needed in age of information and communication technology. And the presentation is on behalf Mr. Nila, and let's see what we have here.
No sound.
Sorry, I can't hear my voice.
Sorry.
So can I use video by myself?
Yeah, sure. I will stop it. Okay, sorry. Yeah, could you just start? Just open your camera, and I stop the sharing from my side.
Okay, wait a minute, please.
Yeah, because I can hear it, so I thought that everyone can do.
Hello, everybody.
We can
My
hear
name
it,
is
yes.
Kunihiko Takamatsu. Today's title is Informatics, a new academic field needed in the age of information and communication technology. Today, I have 3 topics. The first topic is introduction and research question. This slide shows the recent key terms in higher education in the world. Evidence-based education, EBE, institutional research, IR, learning analytics, LA, information and communication technology, ICT, digital transformation, DX. These key terms are attracting attention in many countries as the centerpiece of higher education reform. Many educational researchers and IR staff are working to determine best practice for managing this data. However, this line of inquiry cannot be effectively pursued using conventional pedagogical techniques alone. If researchers can adequately use informatics such as data science, machine learning, statistics, and so on, then data analysis and prediction will be promoted. And these analyses can dramatically contribute to the development of higher education, just as bioinformatics has significantly developed biology. To quicken this research, we propose the concept of eduinformatics, a novel field of education that combines both education and informatics. In 2018, the term is a portmanteau of education and informatics. This figure shows the concept of eduinformatics. the field of education provided problems to be solved to eduinformatics. Eduinformatics deal with students' data and provides novel analytical methods and concepts for using data in education, similar to bioinformatics. This figure shows the effectiveness of eduinformatics. Eduinformatics is a necessary concept in this age of the rapid development of ICT. Today, a large number of educational data points can be easily accumulated using LMS. Establishing eduinformatics can further accelerate evidence-based education or institutional research and learning analytics, which in turn will improve the quality of higher education. This slide shows our research question. The next is second topics. In 2016, the Cabinet Office in Japan proposed Society 5.0, a human-centered society, in the fifth phase of the Basic Plan for Science and Technology. And the government is currently working to realize it. As a part of the plan, Ministry of Education, Culture, Sports, Science and Technology, next, has explicitly stated the need to strengthen mathematical data science education in universities. In response to these trends, we established a research unit of mathematical and data science education in the existing Center for the Promotion of Excellence in Research and Development in Higher Education within Kobe Tokiwa University. This unit supports not only mathematical and data science education for students, but also the promotion of IR and statistical support for researchers within the university. Notably, we theorize eduinformatics as a part of our work in this unit. This figure shows the second example. In Japan, the importance of the first-year experience at university is increasing as the country has advanced to the universal stage of university. That means enroll rate of more than 50%. In Kobe Tokiwa University, 19 teachers teach the first year experience course, with approximately 350 students in total, and from 16 to 70 students per class. In this class, students gather into groups of about 6. This is difficult for 19 different teachers to evaluate students equally. In a previous our study report that used the Steele-Davos test, we found that the teachers of this course did not evaluate students in a standard way, even though rubrics. Based on our above finding, we create a standard evaluation method, a revised rubric for the teacher to follow. Moreover, we explain the rubric in detail to both the teachers and students of the first year experience course. A multiple comparison analysis of the results show no significant differences in the teacher's evaluation of students. In Japan, Ministry of Education, Culture, Sports, science and technology promote the visualization of learning outcomes. So, we developed a web-based radar chart system of Tokiwa competencies. Tokiwa competencies consist of 9 abilities to help students independently measure their competency level. We designed this web-based radar chart system to be compatible with both computers and smartphone because most students now use a smartphone instead of a computer. In Japan, dropping out has become a major problem in higher education. So we analyze student dropout by using data from current, graduated, and dropout students. At the time of our analysis, we had 3,495 data points in our database containing 1,246 items of numerical value. We obtained results with these data by processing them using machine learning techniques and 2 methods. A logistic regression is the test correction rate exceeding 95%. A random forest is the correction rate of about 90%.
Okay, is it done? Because I think that the video stopped at minute 11. Okay.
This figure is final slide.
Okay.
With the development of ICT and the accompanying evolution of LMS, large amount of educational data can now be accumulated more easily and quickly than ever before. However, there are many cases where the accumulated data are not fully used for educational improvement. This is because the systematic methodology for handling data has not been established. Edu informatics as a new academic field work to fill this gap. Edu informatics is not just statistics, but the new interdisciplinary field that integrates pedagogy with statistics, mathematics, and informatics. Edu informatics crucially help prevent individual disciplines getting caught up with trivial matters, losing sight of a big picture, and settling for temporary solutions when handling educational data. And edu-informatics enable us to make local and global analysis and predictions based on educational data and stand to accelerate higher education reform. Thank you for your attention.
Okay. Thank you for the presentation, for the creative idea. And now we will get back to Professor Tuba for his questions. So.
At one point, you mentioned that the
Thank you very much.
was not uniform in the beginning, but after some kind of new system set of advices, it was more uniform. So what was the main features of that advice system? What kind of advices you used to make the grading system more uniform?
Usually, I use most students use a smartphone. So now I prepare to the main system is a Unix or something, and provide the device is mainly a laptop or smartphone.
Okay.
Okay.
Is there any question, please?
Mhm.
Anyone from the audience? Okay, so you are lucky. You got one easy question. Okay, then thank you for that.
Thank
And
you
now
very
we will
much.
thank you. And now we will move for our last presentation for today with also an interesting idea. Now we will move to Romania with Mr. Nila. The paper is titled as Eclair and Artificial Intelligence Research and Experimentation Workstation. On behalf of the co-authors, could you please just share your screen, Mr. Nila, and go ahead with your presentation. Thank you.
Okay, can you see my screen?
Yeah, we can see it and we can hear you clearly. Go ahead, please.
Okay. Hi,
Thank you.
everyone, and welcome to our presentation on Eclair, an artificial intelligence research framework. I'm Constantin Nilă, and together with my colleagues from the Ferdinand I Military Technical Academy, we are excited to share with you our approach to an integrated AI experimentation platform. Here is a summarization of our submitted article and the backbone for our slides. Now, as a quick intro into our work, we, like many other researchers in the field, we looked for a fast deployable solution in which we will try our concepts and demonstrate principles through various experiments. Luckily, there are many solutions freely available in the open space. On the slide, you may find few examples like Google Colab and Datalore. Nevertheless, some research impose working with sensitive data that limit our ability to use cloud service providers. Moreover, we would like to share a framework that can also be used by other researchers to collaborate and to validate their findings. As a small allegory into our motivation, we started thinking like in the past. If in the past we have researchers that looked in front of them and observe phenomena, nowadays we are staring in front of computers and try to explain the same phenomena to machine learning algorithms. To address this objective, we consider, of course, the main operating systems. We starting from open source. Any search regarding base system for machine learning or AI development will return systems like Ubuntu, OpenSUSE, Debian, or CentOS. Other honorable mentions are Scientific Linux, Arch ecosystem, Linux Mint, and the Red Hat family. We also have some commercial options like MLOS from the BrainToy or the industrial leading iOS for machine learning from cnvrg.io. If we look for a user-friendly environment, we've had to switch to a cost solution. In this category, we have, of course, Windows-based systems. Although we are looking at a non-open source platform, we encounter some advantages like seamless driver integration, especially for the GPU, and the fact that many users are already accustomed to this environment and its feature. Furthermore, we look at macOS, and I'm glad to say that this ecosystem clicked with our vision. We have a stable architecture and a maintained hardware and software. We have privacy and security features in place that are higher than most of the international standards. And as emphasized on the slide, we have a guaranteed performance and stability, which is very important to AI research. So next, we checked if this platform can provide all the necessary instruments for classic data science and AI development lifecycle. We managed to find appropriate tools to fit all the requirements as detailed on the slide. And here is the result. a stable, fully featured system that can fit all IE researchers' demands. Our framework relies on the homebrew package manager, as shown on the diagram. We propose a block architecture where most of the tools stand on the macOS hardware. Although user may add external GPU to increase computation capabilities. This is useful since using GPU can significantly decrease computation time. The user can also access cloud-based resources like Amazon Web Services or Azure. We also provide helpful bookmarks to research resources such as datasets repositories and tool documentation to facilitate the process. As this domain has a variety of components, we try to focus on the objective of the available tools. So we split the tools in 5 categories: mission, data set, setup, exploitation of the resulting set, modeling, and reporting. These 5 categories are as per the IE development lifecycle. The tools can be grouped as shown earlier or left as the macOS launcher returns them alphabetically. And here are the bare minimum requirements for the Eclair framework. We advise that user consider this hash out as a framework will install, but the latency may become unbearable. The installation is very straightforward. All that the user may need to do is run the shown command. And here is a scroll of the installation script. As a different party maintains the base system, integration can be challenging during the system upgrades. Moreover, the lack of a broad
Sorry, it's hanging. Could you please just make sure that the cursor is moving? Also, we can't hear you. Sorry, I'm afraid that we have lost them. No, sorry, Master Bay, you are muted now. We can't hear you. Could you please just unmute yourself?
Just a second, I lost the connection.
Sorry. I'm really sorry for that. Sorry.
Yeah.
Okay, we can wait.
Can you please tell me where?
Yeah, go ahead, please. Yeah.
Advantages. Okay.
Yeah. If you need to explain another idea, just get back to it. It's fine.
Okay. Have you seen limitations?
Yeah, we can see the limitations now. Go ahead. We have stopped from here.
Okay. So starting from here, the lack of a broader audience for testing the platform has showcased a limitation of our approach. Another limitation, of course, is given by the fact that some tools still require emulation or virtualization to work properly in the system. We can not end our presentation without highlighting the advantages of the Eclair framework. The advantages are provided by the combination of Homebrew with Docker and are like change management, control, and resistance to cyber attacks. As an extra instrument in any data scientist arsenal, Eclair is a very helpful tool that can be used as is and provide repeatable results. This concludes our presentation. You can find, of course, the references under the exhibit link and more out of our research interests. Thank you very much for your attention. And if you have any questions, I will gladly answer them.
Okay, thank you for the great presentation, great idea. Okay, then as we are lucky, we don't have questions on the chat box, but for sure, the Professor Tuba will have his valuable input. The mic is yours.
You mentioned that one major limitation is a small pool of testing audience or something like that. But if that means that few people in the artificial intelligence community really use Macintosh operating system, then that's the problem that will not go away easily. So how do you deal with that?
So the macOS is used in the AI development community. It's second that by Windows. The first option is of course Ubuntu. So we consider that we have some audience. The limitation was given by the fact that we launched the product, but not very many people have tried it and experienced it. Another method to address the limitation that we consider for future work was to adapt the Eclair framework for Debian system and have like two major distribution, one for macOS and one for Debian.
Okay, thank you.
Okay, thank you. So I have a question from the audience. Um, but it will be easy. I'm really pretty sure about this. One of the audience asking about what kind of cyber attacks you tested on this framework.
We limited the cyber attacks testing part. The system is pretty stable by itself. We try to address like broader attacks, like specially crafted exploits that were made public this year, like
Okay.
2021.
So thank you for the clarification. Is there another question before moving to the next part of the session? Okay, all is great. So now time flies when it's interesting. Thank you for being part of this session. I sincerely thank our authors for the excellent presentation and contribution in this session, and all our participants to being part of international conference. I hope the session was informative enough, and thanks again for the contribution and the great and valuable inputs. All presenters will for sure get their digital certification through email within 2 working days. Further, all papers for sure have already forwarded to Springer. The publication takes 5 to 6 months, and kindly cooperate with the team of Words for 2021 to get things progress faster and as expected. I also thank the session chair, Professor Tuba, for chairing this session, for the questions and for valuable inputs. So, could I mute himself or herself? Okay, and please, Professor Tuba, accept our appreciation on behalf of Team S4 and everyone in this session for your kind attendance, contribution, and inputs, and the appreciation of global knowledge research. Thank you, everyone. Thank you, Sarah, Madam. And at the end of this session, I will request everyone to turn on the camera, even though it's virtual, it's not face to face, but we still have a time and a chance to get beautiful pictures for our memories. Hopefully next year we will meet everyone physically, and now we will take up our picture. Okay, say hi, then cheers. 1, 2, 3. Okay, we are done. So thank you, everyone. Have a nice rest of the day, and for sure you're welcome to attend the next sessions. See you next year physically, and please stay safe. Thank you, everyone. Take care.
Thank you. It was a pleasure. Yeah.
Thank you.
Thank you very much from our side as well. Thank you for attending this session, and look forward to attending the future sessions as well. Thank you.
Thank you. Take care.
Thank you
Bye-bye.
for all.
Stay safe. Bye-bye. See you next session. Bye-bye.
I think we are again on for next 5 minutes with this session, and we will be closing this session, and
Yeah.
we will be again rejoining the session at around 2:15.
Yeah, after half an hour, we will.
Half an hour.
Yeah, we will see you in the next session. Thank you.
Perfect. Thank you.